Hi everyone, these are some harder trig identities that we're going to do, and I'm going to go ahead and just get started because I was going to try to do 5 on this, which is going to make the video kind of long, but just remember that we want the left side to equal the right side, so I'm going to manipulate the left side here and write everything in terms of sine and cosine. And just write this in terms of sine and cosine. So I'm assuming you all know your basic identities before you watch this video. Okay, and this one is going to have to be done via a common denominator. So it's a complex rational. So my common denominator in the numerator is cosine. And so that would put that over 1. So you kind of just cross here. So we're going to get cosine of theta times sine squared of theta minus sine of theta. And in the denominator, you do the same thing. My common denominator is sine of theta, so you just kind of cross. So multiply here. So this is, you're not actually cross multiplying, but it's kind of the same thing. Minus cosine of theta. Alright. So on the next slide, what I'm going to do is go ahead and distribute the tops here. And I'm going to get sine squared theta cosine theta minus sine of theta over cosine of theta. And then for the denominator, it's the same thing. Distribute cosine squared theta times sine of theta minus cosine of theta. Now here, what I'm going to do is go ahead and factor out, since I divide both of these pieces by sine, I'm going to factor out sine of theta. You get sine theta cosine theta minus 1 over cosine. And for the denominator, do the same thing. Factor out a cosine of theta, and you get cosine theta sine theta minus 1 over sine of theta. Now, if you remember with rationals from Algebra 2, that basically when you're dividing this, it's just like multiplying these two. I'll just write it out. So when you're dividing, what you're really doing is writing it as sine times sine of theta cosine of theta minus 1. So you just write your numerator part, and then we're going to multiply. When you multiply, instead of divide, we're going to flip this. Okay, so this goes on the top. So we're going to write sine of theta over cosine of theta times cosine of theta sine of theta minus 1. And what happens is these two are the same. These are switched, but it's still the same value. So you cross those out, and you get sine squared theta over cosine squared theta, which equals tan squared theta, which is the result we wanted. Okay? And this is the one that my students tend to have problems with. The next ones are a little easier, actually. So let's go and try this one. We have secant of theta minus cosine of theta, and we want this to equal sine of theta times tan of theta. Alright, so I'm going to work on the left side here and rewrite this in terms of sine and cosine. So we have 1 over cosine of theta minus cosine of theta. Go ahead and put it over 1. Get your common denominator, which is cosine. And what I'm going to do is just cross here. So I'm going to get 1 minus cosine squared of theta. Alright. And this equals, at the top here, this equals sine squared. So we get sine squared over cosine, which is like saying sine squared, so sine of theta times sine of theta, whoops, why did I write cosine? Times sine of theta, because that's two of them. It's two of them, over cosine of theta. Now on these, this set here that I'm doing, you really have to always keep your eye on the final answer. It's not going to just magically appear. So what I can do is write this as sine of theta times over 1 times sine of theta over cosine of theta. You have to keep looking at this. This equals that. So I just kind of split it up. And we already know that this is tan of theta. So what we have is sine of theta times tan of theta. Because this equals tan. So it's not too bad. You just, on these, this set here, you really have to keep looking at your end result, your desired result. Okay, the next one is kind of the same thing. You have tan of theta plus cotan of theta. We want that to equal secant of theta times cosecant of theta. I'm going to go ahead and work on the left side here. So this is sine of theta over cosine of theta plus cosine of theta over sine of theta. Now keep our eye on what we want here. You might even want to rewrite this. This up here, this just to see what it looks like, that's 1 over cosine of theta times 1 over sine of theta. And we just want it to look like this one or this one. Remember, you can work on both sides, you just can't cross. So I'm going to continue on, get my common denominator here, which is cosine theta times sine of theta. And you're just going to cross here, and that's going to be sine squared plus cosine squared. Now we know sine squared plus cosine squared is 1 through our Pythagorean identities. So we have 1 over cosine of theta times sine of theta. And keeping our eye on what we want, we could also write this as 1 over cosine theta times 1 over sine of theta. And it matches, and you could just say that, or you can continue on and say, well, this is secant of theta times cosecant of theta. Okay, so that is that one. The next one is 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta equals 2 times secant squared of theta. And again, if you want to know what that really looks like, that's 2 over cosine squared of theta. So just keep in mind what our desired result's supposed to be. So I'm going to go ahead and my common denominator is going to be 1 minus sine of theta times 1 plus sine of theta. Then I'm just going to cross multiply here. So that's just going to be 1 plus sine of theta plus 1 minus sine of theta. Now, this right here is like your a minus b times a plus b. And we want it to equal a squared minus b squared. So the denominator is just going to be 1 minus sine squared. In the numerator, we have these signs cancel, and we have 2. We also know that 1 minus sine squared is cosine squared. So this is 2 over cosine squared of theta. Now, we can either write our answer like this and just match it up to this one, Or I could go ahead and write that this equals 2 secant squared of theta and match it to this side, to this one here. So it matches there. Either way, both of these would be valid answers. Okay? And the next one we're going to do is this one. 1 plus sine of theta over 1 minus sine of theta minus 1 minus sine of theta over 1 plus sine of theta. Same thing. Oh, well, this is supposed to equal 4 times tan of theta times secant of theta. And again, if you want to write that out, this would be 4 sine over cosine, and then this would be 1 over cosine as well. So this would be cosine squared, or I can just write cosine twice. All right, so something like that. Either want it to look kind of like that or like that. So I have my same common denominator, which is 1 minus sine times 1 plus sine theta. Cross multiply to get 1 plus sine of theta squared minus 1 minus sine of theta squared. All right, and we know the denominator. I'm going to take care of that first. That's 1 minus sine squared is from the previous one, which you know equals cosine squared, which is what we want, because this is cosine squared. But the top, let's handle the top part. So the numerator, this is your a plus b squared, and we know that's a squared plus 2ab plus b squared. And this one's the same thing, but it's minus minus here. So just take care of that. 1 plus 2 sine theta plus sine squared of theta minus, and be careful here because you have to distribute this negative. So that's 1 minus 2 sine theta plus sine squared of theta. Should have left more room. Alright, so plus sine squared theta. And this is all going to be over cosine squared theta, because that's that part. This is this part. Alright, now, so the next page, we're going to clean that up, and we're going to get 1 plus 2 sine theta plus sine squared theta minus 1 plus 2 minus sine squared theta. All I did was distribute this negative here to those three places. And let's just clean this up. The 1's cancel, the sine squareds cancel, and we have 2 sines here and 2 here. That's 4 sines all over cosine squared of theta, which gives you what we wanted. So this is 4 times sine over over cosine times 1. You can do it this way. Do you see where these are the same? And so this is going to be 4 times tan of theta, and this is secant of theta. Or you could have just left it like this, and this equals what we wanted right here. All right? Well, actually right here. Okay, I'm going to do one more. Sorry this video is going a little long, and I'll go a little faster on this one. So the last one is secant theta over 1 minus sine of theta equals 1 plus sine of theta over cosine cube of theta. Now, what I'm going to do is go ahead and look at what I have here, and there's not much I can do. So what I'm going to do, because if I multiply my numerator and denominator, and this is where you have to keep your eye on the ball here. If I multiply my numerator and my denominator by the 1 plus sine of theta, what we get for the denominator is cosine squared, and the numerator is going to be secant theta times 1 plus sine of theta. Now, cleaning that up, I can write this as, I'm going to rewrite this. Remember what we want. So what is secant of theta equal? That's 1 over cosine of theta. So I'm just going to rewrite him as 1 over cosine times 1 plus sine of theta over cosine squared of theta. And what will happen is we get our numerator, which is 1 plus sine of theta over cosine cube of theta, which is exactly what we wanted. So those equal each other. And that's all of this set. The next set is going to be very similar to this set. Thank you and have a nice day. Bye-bye.